we're going to start over. As I said, I want to welcome everybody to today's webinar. It's Discover how carbon dioxide capture can benefit your brewery and the environment. And we're featuring Dalem Beverage Equipment. I'm Kathy Black. I'm the Pollution Prevention Coordinator for the New Hampshire Department of Environmental Services, and I run the New Hampshire Sustainable Craft Beverage Program. And we offer free technical assistance to craft beverage producers to help them become more sustainable. We offer assistance with energy efficiency, water conservation, chemical substitutions, process changes, waste reduction projects, including wastewater and solid waste. And this program's work and webinar are made possible with funding from the EPA. So today, this webinar is being recorded, and the link will be sent to all of the attendees, and it will be posted on the Sustainable Craft Beverage Program website. First, a little bit of housekeeping. We will have question and answer at the end of the presentations. And right now, if you have a question, there is a little bubble up at the top on the left, and it says chat. And if you click on that, it pops out a box to the right where you can type in your questions. And I'm going to admit 2 more people into the webinar. All right, now I would like to introduce today's guest speakers. We have Eric Dean. He's on the left here. He is the head of U.S. sales for Dalem. Eric has more than 20 years experience spanning mechanical, industrial, structural engineering, as well as automation. Currently, he focuses on product development and launch for Dalem. And a fun fact, Eric had a brief stint with a hoppy brewery in Wisconsin where he worked cleaning out mash, the kegs, getting the malt and grain ready and cracked for the day's brews. And he also owned a craft beer bar, Steel Street Hops, in 2018. And this bar had 20 taps and about 50 cans, as well as craft spirits and wine from around the globe. Next, we have John Kidrowski, and he's in the middle here, or the next person. He is the managing director of the USA team at Dalem, which is based in Wisconsin. John worked for more than 30 years for Miller Brewing in process engineering. He is a professional engineer, and he's focused on industrial mechanical engineering. And a fun fact is that John's favorite adventures were in the Dominican Republic at Presidente Brewery, where for 8 years he led their expansion plans, and he installed the country's first wastewater treatment plant. I think that's pretty cool. He also enjoyed working with Leinenkugel's team in Chippewa Falls, Wisconsin. And last, we have Paul Graham joining us. He is joining us by phone, and he is the owner, president, and brewmaster for Central Waters Brewing Company in Amherst, Wisconsin. Paul is a 25-year-old veteran in the craft beer scene, and he's been at the helm of Central Waters since about 1998 when the brewery just started up. So that brewery started as like a 200 barrel a year brewery and about a 2,500 square foot building, and now is a 12,000 barrel brewery and has one of the largest barrel aging programs in the nation. In 2007, he moved the brewery to the current location in Amherst, Wisconsin, and Paul has been focusing on renewable and sustainability initiatives with a long-term goal of becoming a net zero emission brewery. Kudos on that. A fun fact here, Paul was featured in an episode of the podcast Forward Sustainability, which was produced by the University of Wisconsin Sustainable Management Program. So at this point, I'm going to turn this over to Eric Dean and let him take it away now. And I'm going to go ahead and admit the last few people into the webinar.
Sure, yeah, we got a couple posts too that people can't see the panelists, but first off, definitely want to thank Kathy and the New Hampshire Sustainable Craft Beverage Program for helping us put this together. I reached out to Kathy a couple of months ago to see what we could do, so it's taken a lot of people, great marketing team, John, Kelly Featheroff, and what have you, to pull this all together. So thank you for doing that for us, and Paul definitely for agreeing to be on the panel as well. So we'll just John's going to be taking over the first part of this, and it's primarily the engineering portion. Again, this really isn't a sales pitch. It's honestly, we're just trying to help you out to tell you, how CO2 recapture can benefit your brewery. So I'll let John take it away with the next slide.
Thank you, Eric. Thank you, Kathy. Okay, first I give you a little background on our founder, Kim Dalem. I've known Kim for about the last, I guess, 20 years. He's the founder of Dale Beverage Equipment, and they're based in Denmark. He lives in Odense, Denmark, which is about an hour and a half directly west of Copenhagen. Kim has a master's degree in business and a doctorate in engineering. He has quite a long career, I think about close to 30 years in brewing and beverage. He was the CEO over Sander Hansen. Sander Hansen made a very advanced tunnel pasteurizer for breweries. Based on that success, Sander Hansen was purchased by Krones, and then Kim moved to Krones, and he was the vice president of product development there for a few years. After that, he went to Alfa Laval, and he was the director of brewing products for them, and that's where he became familiar with systems that they offered, such as deaeration as well as membrane filtration. He left there for an opportunity at Union Engineering. Union in Denmark is a very large and well-known CO2 gas industrial machinery maker. Let's say they have been for years the leader in industrial gas collection, focusing basically on CO2. They got bought out by Pentair, I guess, about 4 years ago. And Kim left there. And with his background in the beverage side, he had seen a lot of innovation that went into all the large brewing, was available to all the large brewers, but not available to craft brewers. So he started, one of them that he really enjoyed working on was the membrane filtration for breweries. So he decided to pursue that and see if he could scale it down to craft brewers. Next slide, please, Kathy. So basically, he was working with a small brewer adjacent to where he lives in Denmark. And Andres, they were working on membrane filtration for that brewery. And as a small scale, and Andres said, well, why don't you just also work on CO2? So basically, because of the knowledge Kim had from working at Union and the contacts he had with the personnel there, he decided to focus on CO2 collection for craft brewing. And that's where we are today. Next slide. Today, we're going to be talking about a few things here. And like Eric said, I'm trying to keep it basically on the technical side for this part of the presentation. What's driving CO2 capture? How fermentation CO2 capture works? Potential benefits for you? Requirements to build CO2 capture into your brewing process? And an overview of the Dale USA operation and how we can support we can offer you. Next slide. There are probably four drivers right now. The first one is up in the top left corner there. Over in Europe, CO2 collection is actually off to a very good start in the craft brewing side. Basically because the people in Europe seem to be much more in tune to the carbon capture. So, and there are countries over there, such as England, that offer substantial benefits, monetary benefits to people that are installing CO2 capture on a craft scale. Also, there are some climate incentives. Catherine, can you comment on that, please?
Well, in the United States, there is 45Q, which is a tax incentive for carbon capture and sequestration. As I murder that word, I apologize. But it's limited to more of the production facilities, metal production, power plants, oil, that kind of thing. But with some of the new infrastructure money and things like that, there is a possibility that new things can open up. We are looking into this in Region 1, myself and others, and we will be sure to let you guys know if we come up with anything, if we find out that grants are opening up or tax credits.
The second driver in the top right quadrant for the recent increased interest in CO2 capture is the war in Ukraine. The gas supply got cut off basically completely to Northern Europe. And for instance, in England, there are two CO2 generation facilities, and they both make fertilizer, and CO2 is a byproduct of the fertilizer manufacturing process. When the shortage of the shortage of natural gas in Europe occurred, basically these plants shut down, and available CO2 or available natural gas was being used for industrial and for heating. So their prices skyrocketed if they could even get it. At one point, they were at $3 a pound for CO2 in Europe, or sorry, in England. So that's down in the left-hand corner, the quadrant, the price goes up. Well, it went up in Europe, but also went up in the United States. And that's for a couple of different reasons, but one of them, again, related to natural gas. Because there's a shortage of gas in Europe, the LNG, the liquefaction of natural gas, took off in the United States. So we're exporting more gas to Europe. That drove up prices and caused shortages. Throw in COVID and logistics, and basically the prices went very high in the United States, and even to a point where people could not get CO2. In the fourth quadrant, we're just going to mention that, to a small craft brewer, CO2 shortage is a big problem. If a craft brewer cannot get his product to the retailer or to his local bar, wherever he's selling, it is a disaster for them. They spend a lot of time and effort to get these accounts, to get tap handles, and if they cannot deliver product, it's a real issue for their business. Next slide. As far as the environmental impact of collecting your own CO2, we figure that a 20,000 barrel brewery should be able to recapture 68 tons of CO2. When you add in the manufacturer, if you were purchasing CO2, the manufacturer of that CO2 plus the cost to deliver it, the over-the-road delivery considerations, it basically doubles the amount of CO2 that is saved. So we go from 68 to 136 tons on a 20,000 barrel brewery. In the US, that's equivalent to 44 cars taken off the road by avoiding that. And here's a little, this is for Andy Gadd from Gadd's Brewery.
So we've introduced carbon dioxide capture and reuse because brewing involves fermentation. Fermentation involves carbon dioxide, and it's a bit daft to let the carbon dioxide go up into the atmosphere. Now technology is available to capture it, it's a no-brainer. Half of the beer we make goes into traditional casks, where the beer carbonates itself through a secondary fermentation. However, that leaves the other half of the beer that then has to be force carbonated, and in order to keep the carbon dioxide in the beer during packaging requires a lot of extra carbon dioxide. So on the one hand, you have the evolution of carbon dioxide from a fermentation going up to atmosphere, and on the other hand, you have the packaging side of the industry buying carbon dioxide in from wholesalers who happen to mainly get it from fertilizer production. So it seems a bit of a no-brainer to try and say, well, okay, let's stop it going to atmosphere and let's start using that on our packaging side.
It's been extremely interesting to see the possibilities for small-scale Scope 1 carbon capture. It's something that I will be exploring in greater detail now, knowing that there is technology available.
Next slide. Increasingly, domestic craft brewers are investing in the technology. And Paul from Central Waters, do you have a few comments on this? Did we lose Paul?
I think he's muted.
There we go. Oh, we're playing with the mute function. Try again, Paul.
All right, can you guys hear me now?
We got you.
Yes.
Yes.
All right. Well, good afternoon, everyone, and thanks for having me here. I got to admit that we're pretty excited to be coming on board with Dalem. You know, to see small-scale CO2 recovery systems being developed has been really a dream of mine for a long time now. And at this point, we're scheduled to be operating near the end of this month or early next month. And any of you that are heading up to the Craft Brewers Conference in Nashville, you'll be able to see our unit on the trade show floor. I'm just going to speak a little bit about a couple of reasons on why we're jumping on board with Dalem. And of course, I'll stick around in case there's any questions I can help with. A little bit about Central Waters. We've been in operation since 1998. You know, and as you heard earlier from Kathy, we're currently producing about 12,000 barrels a year. Sustainability has been at the forefront of our operation for the last 16 years, with a big focus and goal on net zero emissions. Obviously, the CO2 recapture system helps us achieve a vital step in that process. We've done an incredible amount of renewables and energy efficiency measures here at the brewery that keeps us at the forefront of the industry. So we're really excited to see for this unit to come on board with us and really help it fit into our goals. The second point on the slide there is, we realized when we made the decision to focus on sustainability that it's a long-term objective. Our company makes long-term investments in equipment that doesn't have the return on investment that compares to, sort of your standard production equipment. That being said, the ROI of this unit is incredible when we compare it to other things we've done. The average photovoltaic system that we install has an ROI of about 7 years. Solar thermal that we've done is almost 9 years. And many of the energy efficiency upgrades that we've done, we've seen anywhere from 5 to 10 years return on investment. When we're talking about a 2 to 3 year return on this system, it really makes it a worthwhile investment. The third point on the slide, really our goal is to gain independence from carbon dioxide suppliers. We're all getting beat up with supply costs in the brewing industry right now, really no matter what size we are, and carbon dioxide is no exception. Not only did we see the cost skyrocket and surcharges applied during the pandemic, but supply consistency became a large scare for our industry. Costs have stabilized now, but to see pre-pandemic pricing will most likely never happen again. We all know that without CO2, we can't produce beer, plain and simple. And as John said, in today's competitive environment, nothing is more important than ensuring preservation of our shelf space and tap handles. And the fourth point on the slide there, in all reality, consumers' expectations of brands are rising. Companies really need to meet those expectations to maintain and improve brand loyalty among their audience. Climate change is an increasing fear for many people, and consumers want to do their part to reverse the damage to the planet. They're demanding more environmentally friendly companies, and it is expected that they will push that demand further in the future. With an eye toward green practices, consumers are becoming more influenced by companies with sustainable products. This unit is really a simple, cost-effective method to make your company stand out among your peers when consumers are making choices. So that's all I got for you guys.
Thank
That
you,
was pretty
Paul.
good.
Next slide. Okay, how does it work? Well, basically, we recover the CO2 from fermentation. We purify it, and we'll go into that in more detail here shortly. We liquefy it. We store it in pressurized containers, and then it was taken in through a vaporizer and reused in your process. Everything stays within the brewery. Next slide. Okay, this little chart here is going to show you, this could be a typical installation. It's not for everybody, obviously. Every brewery is different. But basically, it starts from fermentation. We come off the top of the tank. go through some pressure valves, back pressure valves, to increase the pressure probably to somewhere between 3 to 5 psi on the fermenter. That's to get the gas through the lines, and it goes over to the what we call a foam trap, which is at the base of the machine normally, or it could be at the fermenters, again, depending on installation. The purpose of the foam trap is basically to ensure that liquid does not get into the CO2. It does not cure foamers, and we'll talk about that in a minute. The gas then goes through the CO2 unit itself where it gets pressurized, chilled, and goes into a liquid tank. From the liquid tank, it goes out to the right side there. It'll go through an evaporator into your process. Most of you probably have an evaporator already, even with purchased CO2. And if there's any buildup of pressure inside the storage tank, it goes from the storage tank back into the foam trap, and we liquefy it. So that's basically the flow diagram in a nutshell. Next slide. A little bit about how it's actually turned into a liquid. From the phase diagram here, if you look at the bottom left, it says conventional unit. This would be a unit that you would find normally in a larger brewery. They're using ammonia refrigeration. They compress the gas. They compress the gas from the fermenters to 240 psi. At that pressure, you have to go to minus 17 F in cooling to make it change into a liquid, to change state. The Dalem system is we compress to 600 psi, and then we can liquefy at 35 degrees Fahrenheit. Now, the reason we did that is because with a conventional system, when you go to 240 psi, breweries do not have refrigeration to get down that low. Normally, your glycol system is 25 to 35 degrees, somewhere in there, whatever you need to maintain your fermenter temperatures. So a conventional system will require an additional refrigeration unit attached to it or somewhere in the brewery to make that, to get down to minus 17 F. With our system, we tap into your house glycol system. In other words, the same cooling system you're using for chilling fermenters or making chilled water or whatever. So that's really the difference between the technology of a conventional technology versus what we call the Dalem unit technology. The compressor was developed again by Kim Dalem. It's a proprietary compressor, 3-stage, and we'll talk about that in just a minute. Next slide.
Apologize.
Okay. So basically, we'll start on the left side and work across to the right on our collection process. The CO2 is collected from the fermentation process. Normally, we'd like 20% headspace on the top of the fermenter. And generally speaking, after about 21 to 24 hours or so is when we would start collecting. We need 96% pure gas coming off the tank. Now, the reason you need the high purity is because, referring back to the phase diagram, coming off the tank is going to be nitrogen and oxygen, basically 78% nitrogen, 20-some% oxygen. You cannot compress and liquefy those two gases at the pressures and temperatures where we at. You have to get much higher pressure and much lower temperatures to make liquid nitrogen and to make liquid oxygen. So if those gases are mixed in with the CO2, they tend to do what we call lock up the condenser. So that's why we wait until we get 96% pure gas. Next slide. Now we're into a foam trap, and again, the foam trap is just to keep any liquid water from getting into the liquefaction unit. It will dissolve some foam, but if a foaming fermenter comes on, you would disconnect it from the foam trap and let it go to the floor into the drain. Next slide. This is a scrubber. It's basically gas goes in the bottom of the tower, and water is flowing across what we call saddles, which increases the surface area of the water spray. And the gas is going up, the water's coming down, and in the process, the water is absorbing flavors and odors from the CO2. This is probably the most important step of the liquefaction process to make sure that the gas coming out is odor-free. Next slide. Now we're into a 3-stage compressor. We compress the first stage 150 psi, the second stage 300 psi, and the third stage 600 psi. Between each stage we are cooling, again with house glycol, and the idea of the cooler is to condense any moisture that's coming through with the gas. We take the moisture out at each step of the compressor. Next slide. We go into dryers. One thing at the temperatures we're going to be working at with liquid CO2, you don't want moisture in there. So we go through 2 desiccant dryers. You go through, in this case, let's say you're going through the left tower while the right tower is in regeneration. You regenerate with heat, electric heat, to drive off the moisture. But basically, it's taking the dew point of the gas down to, I think it's minus 62 F is what we get down to. Next slide. We're going through an activated carbon tower. The carbon is used to remove the sulfur compounds, the sulfides basically. This is the rotten egg smell. So this is where it comes out in the process. Next slide, we go through a condenser. It's basically a coil arrangement, a serpentine coil. In our case, they're different shapes, but ours is a serpentine coil. As the hot gas goes into the bottom, we're running house glycol counterflow through it, and basically as the gas travels up, it cools and turns into droplets of liquid CO2. At the top of the condenser, we have a vent, an automatic vent, and what we're looking for there is oxygen, because the gas that cannot be condensed will travel to the top and collect at the top of the condenser. So periodically, based on concentration or the contamination, I would say, with oxygen, we vent that gas off the atmosphere. Next slide. This is called a reboiler. It's what it basically is doing is heating up the liquid CO2 so it boils, so it bubbles, and that drives off more oxygen and nitrogen from the liquid itself. It makes this ability to get down to very, very high purity of CO2. From there, we go to a CO2 liquid tank. And in our case, if there's any flash gas or any venting from the CO2 liquid tank, that goes back over to the foam trap and we recondense it. So it's basically no losses there from the venting of the liquid CO2 tank. Okay, so back to our circular diagram. CO2 collected from fermentation and used for tank counterpressure purging can be recollected, purified, and liquefied over and over. So in other words, if you're coming off a bright beer tank and you empty the tank and you've got 10 psi of counterpressure on it, we can take that back into the system. It's pure gas. We can take it back into the system and take the tank down to like probably 3 psi and then liquefy that gas for reuse again. That's why it's called circular, because once you use it, we can reuse it again and keep it in the circle. An appropriate sized unit in proper operation will recapture probably 70 to 75% of CO2 fermentation. This, unless you are doing carbonated beverages such as water or sodas, you should be self-sufficient in a normal brewery. At 70-75% collection, that would be enough for your canning operation, your racking operations, and tank counterpressure, etc. So the important part is getting the 70-75% collection rate. Next slide. How much CO2 is generated for fermentation? It's pretty simple. If you have less sugar, you're going to have less CO2. And sugar refers to basically the gravity of the brewing that you're doing. Generally speaking, if you want higher alcohols, they put in more sugar extract, as we call it, fermentable sugars. So less sugar, less CO2, more sugar, more CO2. Rule of thumb, and we use this just for rough design thing and talking numbers, 8 to 10 pounds per barrel is usually generated, pounds of CO2 per barrel. So we use 9 pounds is a good talking number. That'll change again based on what your how much sugar is in your wort. Fermentable sugars are in your wort. Next slide. So from a typical, these are happens to be the 3 size machines that we make, or the 4 sizes, sorry. But for a 5,000 barrel brewery, you should be able to collect 17 tons, and the remission would be 44. That should be 34. Our numbers did not get, our numbers are not correct here. They should be double. So I think the slide is messed up a little bit, but basically the tons collected, which is most important for a brewery that wants to be self-sustaining, are 17, 34, 51, and 68. So that's your potential. So, you can look real quick at this. If I can collect 68 tons, how much am I buying today? And that's easy enough to figure out from your purchase orders, right? Just figure out what you paid out. But these are good talking numbers. Okay. So the benefits financially, depending on the CO2 prices, you could have a 1 to 5 year ROI payback on it, as Paul mentioned. It ensures a reliability of high quality CO2 and increased independence from CO2 shortages, price increases, and regulations. Again, everything that Paul mentioned. From the environmental side, this is the lowest hanging fruit and just makes the most sense. It's obvious. I mean, you are venting CO2 from one end of your brewery and buying it from a truck on the other end. It really does not make that much sense. Every large brewery that's designed has CO2 integrated into it from day one. It's common practice. So that basically the craft brewers are just catching up to where the large brewers are already. 1 ton recaptured saves 2 tons from being released. And as Paul mentioned, it demonstrates commitment to sustainability to your consumers and community. Next slide. Okay, what's required for a craft brewer to get into this? First, you have to do the piping from the fermenters to the CO2 collection. It doesn't have to be piping, it can be hoses. This is probably the second most expensive part of the implementation. You need foam trap or traps. Some people put a trap right at the fermenter they're collecting from. They're sort of portable traps. Others just have one trap right at the collection unit. Though these are not really expensive items to implement. You need the CO2 liquefaction unit itself. That's probably you're going to be your major expenditure. You need adequate liquid CO2 storage to be independent. We say you probably need between 3 or 4 times your usage in storage. So in other words, if you're using 2 tons a week, if you're purchasing 2 tons a week of CO2 and that's what you're using, you probably need somewhere between 6, 7 tons of storage minimum. The reason being is the CO2 collection and generation is not necessarily balanced with the packaging that uses it. When you start collecting from a fermenter, the fermenter doesn't know the difference between, or yeast does not know the difference between Saturdays, Sundays, holidays, etc. So you have to have a place to go with the CO2 as you're liquefying it to keep it until packaging starts up again on Monday or Tuesday, whenever that is. So for these swings, you want to make sure you have enough inventory. The one thing you don't want to be doing is collecting CO2 and then venting it off because you don't have a place to go with it. And then basically, probably everybody has one of these already, but you need a CO2 liquid vaporizer to go from liquid back into gas stage. Operationally, these are the important steps for a brewing operation. You got to determine when the fermenters are 96% purity. This is done once per wort stream. You basically say, okay, our tank was full at this many hours. You run a purity test and you say, okay, after so many hours, we're at 96% pure. We can go to collect. Normally that period is somewhere between probably 18 to 22 hours. And again, you only do this once per wort stream. You don't do it every day. It's just the first time you run that beer and decide to collect the CO2. You need rigid adherence to process parameters. That means you have to watch your yeast pitching, your fermenter temperatures, etc., because those will affect when your tank is ready to put on collect. So basically, tell you the truth, that's not a bad thing because it drives consistency in your process, which is good for a brewer to be very consistent, and it makes employees aware of it. Fermenters must be put on collect at 96%. This means Saturdays, Sundays, holidays, whatever. When a tank comes on, it's got to be put on collect. If you're brewing 3-4 days a week or 5, you're going to have tanks coming in on Saturday and Sunday that have to go on collect. Again, if you want to be self-sustaining, if you want to keep buying, that's fine. Don't put them on collect. Overfoaming, probably the number one issue here is overfoaming. Some people accept it right now because they're not collecting, but if a tank is foaming, you cannot collect the CO2. There are ways to control it, process ways, temperature ways, etc., things that you can do to correct it. But basically, overfoaming starts at peak fermentation and it does not stop until you're past peak. So that tank is not going to go on collect. Again, if you're doing 30 barrel brews, you're gonna lose 300 pounds of CO2 just because of that. Again, it can be corrected. There are reasons for it, but there's no reason why it can't be corrected. Routine monitoring and maintenance of the unit. You want a key operator designated. The machine there's not much to see on these things when they're running. You're really flying using instruments. In other words, you have to look at, going back to that curve that I showed you, it's basically pressure and temperature. And these machines are all designed with a lot of instruments on them so that you can see exactly what's happening, but you have to know how to interpret it. So you need a key operator designated in your brewery that's going to shepherd this thing through implementation and operation. And finally, treat CO2 collection as your fourth vital utility. Basically, right now, you've got 3 utility systems. If you don't count water and electric, you've got steam, refrigeration, and compressed air. If one of those systems goes down, people react. If you want to be independent, self-sustaining on CO2, CO2 becomes your fourth critical utility. If the CO2 collect system goes down, people have to react. For one reason or the other, whether it's the machine or whether it's the brewing process, a foamer or whatever. So that's it. I think I'll turn it over to Eric.
Yeah, I think a key point too, thank you, John, that was great, is that when we're collecting and you're going through our process, we can go right into your existing CO2 storage tank. So there's not, in the beginning, depending on what your situation is, whether you lease or you own, that's a conversation you have to have, obviously, with your current CO2 supplier. But there are smaller tanks that you can buy that we can supply as well that you can utilize in the interim. But our system is designed and based on the pressures that we're putting out to go right into your existing storage and then vent off that existing storage back into the foam tank. Very small footprint. I had a call the other day and gentleman was worried he needed a ton of square feet to put this in. And honestly, if you can fit a 4x4 pallet in there, you can pretty much squeeze our unit in there. Obviously, you're going to want more space than that for maintenance and what have you. But basically, a 4x4 footprint will get us in. Current ceiling height in Europe is 13 feet. And that's what we're going to have right now with this coming over. So whether it changes in the future, but basically that footprint is where you're at. We can go to the next one. Proprietary compressor, no balloons. There's no balloons on our machine. The compressor was designed to do the work of those balloons. No oil, so no risk of oil contamination in your brewery. We use your current glycol system. Now, if you do not want to use your current glycol system, you can add another glycol system or cooling. We just need to make sure that we're down to those temperatures that we need to condense, and is designed for 24/7 operation. I mean, this thing's on, and it'll start working at a very low volume, and it'll just increase as your volume of CO2 input increases. Plug and play, literally plug it in. It's going to take more than that. We got to get your water hooked up. We have outstanding training videos that we just finished up over in Denmark that were made available to us here in the US. So, you know, we can go over a lot of things prior to installation and during installation. We have a gentleman, Lindsay, tons of years of experience in the brewery industry, like John and Kim, that will go in if need be, and we can get them into your brewery to help with installation. IoT platform for phone app and remote monitoring. So as John mentioned, you have all these systems in place to monitor, but you can also do that from your smartphone. So there's a lot of things. If there's an alarm going off, you should be able to log in and see what's happening. If something's there you don't understand, you call us here in the US. If it's something we don't understand, we'll get a hold of Denmark. So that's the advantage of working direct with us. John coined a term, if you think you're too small, you're not. And I think that's valid, because whether you're 200 barrels, you know, or you're, you know, we say up to 20, we are working with breweries that are in the 40K range. So we are working up to those points. We can do it. It's just going to take a little more time. But it depends on your return on investment. And I think the key with Dalem is this was designed and built to assist breweries in becoming CO2 independent. The byproduct of this great design is it reduces your carbon footprint. So I think that's number one. We're coming at it from an engineering standpoint, and then you get all these great advantages from there. So again, put one of these in, and you know, if you're not concerned with about the ROI and you're just concerned with strictly your carbon footprint, yeah, we can do it for you. So if you're 1,000 barrels, don't be afraid to give us a call. And next one. All right, so our Dalem USA team, John is our managing director. I'm just going to literally read right off the slide. So 32 years with Miller Brewing, process engineering, utilities operations, maintenance, brewery expansion planning and implementation. Kathy told you about his what he did down in the Dominican. John's probably forgotten more about brewing beer than I know, so he's always a wealth of knowledge, and he's right downstairs from me right now. So there's not too many questions we can't get answered here in Algoma. Myself, my background is in mechanical automation, design and build. We used to do, back then they called it tier 3 automation. So we were building fully isolated automated machines for assembly, and a lot of product design. And I used to be the gentleman they would call up to go in and actually spec a machine and do the machine thesis on it. So getting back into this has been a lot of fun. Lindsay, installation and service, chemical engineering, 40 years of brewing experience in large craft breweries. 20 years as an independent consultant on equipment installs and startups. And John, he's in North Carolina, correct?
Yeah, he's in North Carolina.
Yeah. So and all Lindsay does all day is he deals with brewing and craft breweries. So he's a great asset and gentleman to have on staff. Chet is John's son. He's our director of operations. Mechanical engineer, 20 years experience in quality control, operational management, production, assembly, engines, and power transmissions. Again, another great person. He keeps us in line with what we can or can't do. So he's a good guy to have for John and I to keep us in check. We'll go to the next one. And then, of course, John can talk about the Denmark team. But I think the key with this is, you know, we're showing you all these people, and we weren't gonna, but I mean, we're doing well in Europe, so we need a staff to staff that. You know, our staff here is getting going, and I'm sure we're going to add to it soon. But the reality of it is if you need something done, or if you need information on our equipment, you're going to call one of us, and you're talking to the people that deal with it every day. There's not a third party. There's not an intermediary. You're going to talk with me. If I can't answer it, I'm going to get you to John. If he can't answer it, we're going to get you to Kim. So there's a whole host of things. And if you can't get a hold of us in the US, Denmark's 7 hours ahead. So you can probably call our main number and get somebody over in Denmark as well. John, was there anybody on this list that you wanted to talk about?
Probably, yeah, Kristen, who is Kim's wife. She's our legal and finance person, keeps us in line. Frederick over in Europe is the basically international sales director. We have Martin is our new commissioning engineer. He just started with us and doing a good job. Jacob Bauer is our chief engineer over there. And then Anders is the assembly manager. He's with a marine background. Actually, it's a pretty international company, to tell you the truth. And one thing more I want to mention about it is the benefit of working. I guess we are considered definitely a small company, but Kim's name is on the side of the machine. And right now, there are no Dale machines out there that are not working. So if you have an issue like Eric mentioned, you start calling here, and if we can't solve it, we'll go right over there and get right to the designer of the machine. So, and we will get answers. Next slide.
Yep. So again, the IoT platform, online monitoring, remote troubleshooting. Again, we'll have the ability to log right into your machine. So if there is something happening that you can't solve internally, we'll be able to get right into it and take a look at it. But it's a pretty intuitive PLC and platform. So it's very, very user friendly. These are just some basic setups on manifolds. You can have, say you're running 8 fermenters and you don't want to deal with independent tubing or piping for each one of them. We can design manifolds for you where we can put 3, 4, or technically we could put 8 on one if we wanted to. The key to these is hookup is you don't want to be hooking into them until you're at that 96%, because if you do, you could be collecting off of one. And when you hook up, if it's not automated at the time, you could be pushing oxygen through there. So it's the machine's automatically going to shut off and start venting all the gas that's basically infiltrated with oxygen. So, but again, just some basic setups that we've already done at different breweries. Eddie is he's like a spokesperson for us. He's got great videos. You can find him on YouTube or what have you. But he loves the machine. You saw him in the video. That Beer X that was part of that's from the Society of Independent Brewers over in England. So Eddie at Ramsgate and Dale just won a sustainability award at the craft beer at the Beer X. So that's good. Free carbon dioxide, not a lot of that around. Mike Murphy, just like printing money. Obviously Andre is who Kim started with. The joy working with Dale, been great addition to the brewery. And Jan, True Recovery operations for 2 years. They just reached 100 tons of CO2 recovery. And I believe they just became carbon neutral. Did they not, John?
I believe so. Actually, they're located up on an island. If you can imagine this, he had to bring in his CO2 by ferry boat, tank truck on a ferry boat. So yeah, he's very excited about it. He was self-sufficient from day one. Yeah. So he's very happy with the unit also.
Yeah. So some of you that are in our marketing emails right now, you might get a quick blip from him when he talks about that. But yeah, good spokespiece. I think everybody would have good things to say right now. We have multiple detailed CO2 craft beer brewery resources. Scandinavian Brewers Magazine. We're in the ads in the current brewer magazines. We just got very good press. We finally did our press release in the US and they got picked up by the Canadian Craft Brewers Association. Kim's got a great article that will actually be being added to a resource section of our website very shortly here. 4 years of experience. 4 years doesn't sound like a lot of experience. But if you add in the years of experience with large scale CO2, 4 years when there really wasn't anything out there that he could compare it to, and then he's come this far with it. Kind of notable there. But if you want any of the publications, you can't find anything online, just go ahead and shoot me a quick email and I'll get them over to you.
And that's
All
the end
right.
of our presentation.
That
Well,
about wraps it up. I love the Dale and bottle there. I didn't, that was a great picture in the beginning to change that up.
Yeah.
But,
we do
Kathy,
have a couple.
well, there is a question here in the chats, but I'm gonna let you handle the questions and we'll just answer them. That
Sure.
sound good?
Sounds good to me. Thank you, guys. That was a tremendous presentation. I enjoyed it. So we have a question in the United States, or at least in Maine, and I believe this is consistent elsewhere. Most third-party suppliers won't allow you to put the gas in their tanks. Matheson is a vendor here, and that's definitely not going to be allowable. So that's just a consideration. But the question is posed: are there any fermenter sizes that are not ideal for your setup?
Well, for that, shapes more than sizes. If you have 20% headspace, that is really what they think on a vertical fermenter, conical vertical. They think that's the optimum for controlling, for having enough headspace for foam as well as for collection. So 20% is sort of the target on that. The big issue is when you get into horizontal fermenters, trying to evacuate that headspace is not easy. You end up not collecting as much CO2 as you will off of a conical vertical. So if you're adding tanks, definitely don't add horizontals for CO2 collection.
Okay. The next part of the question is, with glycol being used to cool the incoming CO2, can you also use glycol to vaporize the CO2 for use? You know, capture the free cooling and save the vaporization energy.
Yes, certainly. Some people do it. Some people actually, one brewery I worked at, they were actually using it for chilling water down. You have to obviously watch out for the freeze point on it. But if you have enough flow on the water side of the heat exchanger, you can actually use the vaporizing to chill the water down. You could use glycol also. It wouldn't matter. But yeah, you definitely can collect energy off of it.
We have another question. What are the glycol system horsepower and BTU requirements for the larger units?
The biggest unit we make right now is the 30 pound per hour. The motor on that is 2.2 kilowatts or 3 horsepower. And the refrigeration load is about 7,000 BTUs per hour. If you go to a Home Depot or somewhere and try to buy a small window air conditioner, the smallest one you're going to find is about 9,000 BTUs per hour. So putting that as a reference, we're basically window air conditioner size on the refrigeration. There really is there's a little bit of electricity used to regenerate those towers I talked about, but that's really minimal. It's really literally 40 or 50 watts, I think, to generate the heat. So yeah, so it's very low energy compared to the cost of let's say of buying CO2.
Yeah. While we're on that question, real quick, Paul, you're still there?
I am.
Yeah. You have a solar array there. Any concerns with that solar array power in this unit?
No, not at all.
Pretty low requirements
Yeah,
there.
that's the best part about it is you know, the energy coming off of that powering everything here at the brewery. So yeah, it's free energy, which makes it even more free CO2.
Okay.
We have another question. Is there a recommended cleaning or maintenance schedule?
As Eric mentioned, the machine is we call it Brewery Tough. It's designed to run 24/7. There is no cleaning on the machine itself. Maybe on the foam trap, once in a while you CIP the foam trap. Foam can build up into sort of a gooey mess if it's not cleaned out occasionally. As far as maintenance, we recommend it's on a once a year maintenance schedule for the compressor, and once every 2 years on the desiccant and the charcoal. It's really minimal. Again, the machine is designed to run 24/7. And also this compressor this is not, if you think about an air compressor in your garage or something, you hear it running and it's screaming or rattling or whatever. Our machine only runs 60 RPM. So it's a very, very, very slow, it's not a high wear type machine.
And on the something to mention too, on the compressor, obviously with the seals in there, they're not lubricated. So we're working on 2 different programs. If you have the ability or in-house maintenance where that you could basically check, replace the seals and what have you with the maintenance schedule, we would send you a repair kit. If you're not in that situation, it's a situation where we would send you a new compressor and you would send the other one back. So almost like a swap out. So we could work with you in either circumstance.
Also, we do have videos available for valve rebuilds, changing out the desiccant and things like that. We have and also for rebuilding the compressor. I've seen them rebuild it, and Kim can do it in about 3 hours. Of course, he designed it; he's the expert. But I would say if someone in your shop could let's say overhaul a motorcycle engine or something like that, they could easily do it in probably 5 or 6 hours. Replace the rings. It has piston rings just like an internal combustion engine does, basically.
All right, I have one last question. Can the collection from the fermenters be automated?
Yes, it can. There's oxygen sensors that are reasonably priced that can be put on the lines. And then with using pneumatic butterfly valves or whatever, you can switch from we call vent to collect on the fermenter automatically when the purity gets to 96%. Obviously that can get a little expensive, but again, the thing is, to be independent, you've got to collect all the CO2 that's available, and that CO2 is going to come online at any hour of the day or night, Saturdays, Sundays, and holidays. So the automation part is certainly something to think about in your and figure out what it's going to cost when you jump into this.
Great. Well, thank you so much for this presentation. I have learned a lot, and I am very thankful that you were able to deliver this information to us. If you have any other questions and want to hang on the line for a minute, feel free to raise your hand. If not, thank you for joining. I did put in the chat some links to the video that was shown, our contact information, as well as a link to the Sustainable Craft Beverage website. So I hope that you have a terrific day.
Thank you.
Thanks, Paul. Thank you, Kathy.
Thank you. And I do not see any hands raised.
Luke Truman has a question there. It just popped in.
Oh, great. Go ahead, Luke. Or actually, let me see if I can unmute you. You know what? That's going to take me a minute. Luke.
Well, basically, Paul,
All right, Luke. Luke, see if you're unmuted.
Can you hear me?
Yes.
yes.
Yeah.
Yeah, so I just wanted to confirm, did you say 9 pounds per barrel packaged is what you would need to be down to in order for you to generate enough to cover 100%?
Oh, no. When I say 9 pounds per barrel, that's 9 pounds per barrel brewed, not packaged.
Okay.
That's what we expect to collect off of a fermenter.
Okay, that's okay. And so have you done the figuring on what it would take to, like, what you would need to be down to as far as usage per barrel packaged in order to have it be that you didn't need to buy outside CO2?
Basically, I'll tell you what, if you would provide us, get in contact with Eric, we have a model that we run, and we can tell you how much you're going to generate. But see, it varies based on your gravity and your products, right? I mean,
Yep.
So yeah, it could be, and also your package mix if you're doing more cans than bottles or whatever. But basically, we can tell you how much you're going to generate theoretically. We would say, okay, now you're going to collect. We expect you to collect 75 to 80% of that, and then you can look at how much CO2 you're purchasing right now and compare the numbers.
Mm-hmm.
But I can tell you right offhand, I think every large brewer is self-sufficient, if not oversupplied with CO2. And there's no reason, I don't understand why a craft brewer would have an issue being self-sufficient.
Awesome. Thank you.
And I think hopefully I've addressed all the questions in the question and answer tab. I know we missed Luke's there, but I think we got everybody else. But if anybody else would like to ask a question, I'm happy to unmute you, or we can enjoy our afternoon and say adieu. All right. I don't see any hand raised. So thank you again, and we'll go ahead and end the presentation. I hope everyone has a wonderful afternoon.
All right. Thank you, Kathy.
Thank you.
Thank you, Kathy.
Okay, bye-bye.
Thank you.